kids, Shubhamangalam Eclectic Scholar, myself Sudeep. I'll be taking up class 9 physics for today. So we were on chapter number 2, chapter 2 motion. And in the previous video, at the end, we were discussing about two kinds of motion, which is uniform and non-uniform motion. So uniform motion is going to happen when the velocity is going to remain constant. And the other side, the opposite of this will be non-uniform motion where the velocity is not going to be constant. For example, in regular time intervals, if the vehicle or if the person is undergoing the same velocity, the same difference in velocity or same intervals in velocity, for example, in the 0th second the velocity is definitely 0 kilometers, in the first second it is 2 kilometers, in the 2 meters, in the second it is 4 meters, in the third second it is 6 meters. Can you see can you observe a consistency over here? Okay, how do you observe the consistency? 6 minus 4 will give you 2. 4 minus 2 is going to give you 2. 2 minus 0 is going to give you 2. Can you see the consistency of numbers over here? There is a certain pattern, a certain repetition, a certain difference in the pattern. Whereas, if I give you some other example, the 0th second, the distance covered being 0, in the first second 1 meter, in the second 4 meters, in the third second 5 meters, 5.5 meters. Is there a consistency over here? Okay, you cannot see a consistency. 5.5 minus 4 is going to give you 1.5. 4 minus 1 is going to give you 3. You cannot see a consistency of numbers over here. You cannot see the consistency in the velocity. You cannot observe whether velocity is constant over here or not. It is not constant. Okay, do you see the numbers being the same as over here? Can you observe the same pattern as you can see in example number 1 over here? No. Once you observe the pattern in regular time intervals, if there is a regular velocity interval also, if the velocity remains constant, then that kind of motion is called as uniform motion. We have graphs of both uniform and non-uniform motion, which I told you to draw in the previous class for table number 2 and table number 3. You know that the uniform motion graph is going to be a straight line from the origin, and the non-uniform motion can be anything. It can be an exponential or a dipping graph, depending upon whether the velocity increased or decreased as we moved on. Okay, so we have a proper definition over here. The motion of the body is said to be uniform when the velocity is constant. What do you mean by velocity? It is displacement by time. And what is displacement? The shortest distance covered in a particular direction. So if you are covering a certain amount of distance in a certain direction and within a certain time, then that is called as velocity. Do you understand? So here the motion of the body is said to be uniform when its velocity is constant. When the velocity is not constant, it is called as non-uniform motion. Okay, so here, so while considering our examples, we have the time period over here, and this being the distance covered in the respective time period. So in regular time intervals, if the distance covered is a constant, okay, if constant distances are covered in regular time intervals, or if the velocity undergone by a person or a vehicle is constant in regular time intervals, then that is called as uniform motion. There is a certain uniformity in the pattern over here. Okay, there is a certain consistency or uniformity in the pattern 0, 2, 4, 6. Just by looking at the numbers, you can understand, okay, there is a certain, it's a consistent velocity. It is a constant velocity. Okay, while you look at these numbers, you see that the velocity has not been constant. At a certain amount of time, he was driving very slow, then he drove very fast, then again he slowed down his speed. So how can you say that the velocity is constant over here? If there was a cyclist who was riding his bicycle and this was the time, okay, and at this particular time he was driving and covering this much amount of distance. Okay, he covered in the first second 1 meter. In the second he covered 4 meters. This means he increased his speed. The velocity changed. Yes or no? In the third second he covered 1.5 meters, which is again a variation in velocity over here. But when you look at the previous example, in the first second he covered 2 meters. In the second he covered 2 more meters and reached 4. the fourth point, the 4 meter distance. And in the third second, he covered 2 more meters and he reached the 6 meter point. Did you understand? There is a consistency, there is a uniformity in the pattern over here. So let's talk further. We will talk about, okay, observing the motion of the ball on an inclined plane. Everybody knows what's an inclined plane. Where might you have been seeing an inclined plane? Maybe the hospitals, yes or no? Near the hospitals, along with the stairs, there is also an inclined plane for people who use wheelchairs and they cannot climb stairs. So there is a inclined plane provided for them, so that they can just climb up very easily without getting down the wheelchair and somebody helping or supporting them to lift them up or carry up inside. Also in parking lodges, yes or no, to carry huge suitcases. Also in airports, there is a certain platform where you can actually drag your suitcases. The rolling fiction, remember, you can drag your suitcases so that they're rolled up and it is easier for you to carry heavy loads also there. Basically at warehouses also you have certain inclined planes to load and unload the parcels. Basically observing the motion of the ball of an inclined plane. So if we consider this to be an inclined plane and I'm going to roll a ball at the zero, this is the initial position and this is the ball. So like initially the time is going to be 0. So this is going to be the first second, this is going to be the second second. Okay. As I release the ball starts moving. When it is moving in a certain direction and it is moving down, you can see that the speed has increased. Yes or no? And once it reaches down, it stops. Do you understand? When I release the ball from this particular end, it is going to roll down the inclined plane or the slope with a speeding motion, okay, with increase in speed because it is going down the slope. Do you understand? The same thing happens when you're riding a bicycle also, down the slope. If you are at this particular point, you need to control your speed while you're going down the slope, because if you don't control, the cycle is going to move very fast at this particular end. Yes or no? Okay, you will be out of control. But as soon as you reach the bottom, the speed is again back to normal. Okay, it starts decreasing. So there is a certain variation in speed over here if you observe. When I release the ball from this particular end, slowly the speed started increasing, and while it reached the bottom, the speed started decreasing. So this means there is a variation in speed over here. So in this particular example, the speed is changing. Okay. Now let's talk about direction. Is the direction also changing? The ball is going in the same direction. It is going in the same line of motion. So the direction of motion in this particular case remains constant. So in this example where I was releasing a ball from a certain point on the inclined plane, the speed of the ball changed along the slope, but the direction of motion remained constant, class. Okay? Fine. Why do we say that the direction of motion is constant? Because it is going in the same line. It is not jumping or hopping into the other sides of the plane and it is coming on this side and again jumping back. Only then it is called that only then it will be said that the ball has changed its direction. But the ball did not change its direction. It was going in the same direction in the line of motion along the slope. Done. Yes or no? Now let's look at the second activity that we have been given over here in our textbook. Okay, this activity concludes that the first activity that we studied today concludes that the speed changes but the direction of motion remains constant. And the second one over here, observing uniform circular motion. Now if I take a stone and I tie it up with a thread and I'm whirling it with a force. Okay, whirling is like rotating it, basically holding it from a certain end, and I'm rotating it so that it is moving in a circular motion. Remember how do your clothes move in washing machine? That is why there is a name called as Whirlpool as a brand. What is the word? What is the meaning of the word whirl? It is whirling in a pool. And what is the pool? It is a pool of water and detergent. That is why the brand is called as Whirlpool. Whirling is nothing but rotating uh, in a certain motion, in a circular motion. Fine. Hope you have understood what am I trying to talk about. Okay, there is a stone and you have tied up a stone with a thread and you're suspending it from a certain end, and now you have started rotating it. Fine. Once you rotate that particular stone, that stone is going to move in a circular motion. Yes or no? You are applying consistent amount of force, constant amount of force on it, and you're not stopping. You keep on rotating. Fine. This will be the thread, and at this particular end there is a stone and it is rotating, class. So now when we talk about the stone which is going in circular motion, like this be the circular motion in which the stone is moving. Now to draw vectors to it, how can we draw vectors? We can draw vectors something like this. Now you try to understand, is the stone changing its direction of motion? Yes, it is. Do you understand? It was first in this particular position. Then while it was moving in a circular direction, it moved this way. Then it moved this way. Then this way. Then this way. Basically, it is covering a circular path. So whenever an object is covering a circular path, it is going and changing its direction. Yes or no? Do you understand? It is changing its direction as it is moving in a circular path. The direction of motion of this particular stone is changing as I am whirling it. Do you understand? Is the speed changing over here? Did I say I'm going to stop in between and then start again, or I'm going to take a break and then start again? No. I am moving or whirling the stone with a consistent and constant speed. Okay, so when I'm moving the stone with a constant speed, the speed is constant in this case, but the direction of the stone is changing. Okay, if you follow the vectors, first it was in this direction, then it goes in this direction, then in this, then in this, then in this. Is this a straight line of motion over here? No, it has changed its direction. For example, there is a ball. Okay, you have this in Think and Discuss. There is a ball and there is an ant moving on the ball. Okay, the surface of the ball is curved. Yes or no? And the ant is moving over the ball. What do you think? Is the direction of motion of the ball or direction of motion of the ant changing? Yes, because it is moving on a curved surface. It is not moving on a linear surface. It is moving on a curved surface. When an object is moving on a curved surface, the direction of motion of that particular object is actually changing. It is moving in circular motion. Do you understand? So now here, okay, so in this particular example, the direction is going to change and the speed is going to remain constant. Do you understand? Why is the direction changing? Because the stone is whirling in a circular motion. It is covering a circular path. And when we drew vectors on the circular path, we understood that the arrows were not in the same direction. Do you understand? The arrows were changing its direction. Can you see these arrows changing their direction? What are these arrows representing over here? They are representing the vectors. They are not going in the same direction along the board over here. They are changing the direction of path. So in this example, the direction of motion is changing, but the speed remains constant because I am applying equal amount of force to, move the ball or whirl the ball. Okay, this was a second example. Now, observing the motion of an object thrown into the air. Okay, if you were a bowler and you were bowling a ball onto a batsman, so that he is going to hit it or you are trying to hit the wickets. So when you are throwing the ball with a certain force, okay, so when you start throwing it and when it's in the air, the speed is going to be really maximum, but when it is going to reach the batsman's bat or the wickets, the speed is gradually going to, decrease when compared to the speed while it started. Do you understand? So here, when I'm going to throw a ball in the air, okay, if this was the ball which was thrown in the air and it was taking a certain path, the direction of the ball is also changing. Okay, the direction of the ball is also changing and the speed of the ball is also changing. Yes or no? It is different from the speed when the bowler actually started and the batsman actually hit the ball. Do you understand? It is covering a certain length of the pitch. While covering the length of the pitch, definitely the speed gradually changed over there. It varied over there. For example, even if I was taking a ball and passing it to you by throwing it, the speed while it was coming down to you definitely gradually decreased compared to the speed with which when it was being thrown from my end. Do you understand? So there is a change of speed over here. Also, there is a change of direction also. Do you understand? You cannot predict whether the ball is actually going to fall in your hands or it is going to fall in somebody else's hand over here. Do you understand? So both the quantities, the direction of motion as well as the speed are going to change in this particular example. The third one. So let's recall. In the first one, the inclined slope, the direction of motion is the same but the speed is changing. In the second one, the speed is the same because it is covering the circular path and I'm using the same amount of force, but the direction of motion is changing. Follow the vectors, you will understand that the direction of motion is changing. You can also turn the vectors over here. If you turn the vectors, they are going to go in this part. If you turn the vectors this way, they are going to move in the anti-clockwise path. Okay, so now, and third example, when you are throwing an object in an air, you don't know where is it going to fall, you don't know which direction is it going to take, it is completely unpredictable. Plus, the speed varies when you started throwing the ball and when it was in the air and when it reached the particular person. The speed varied over there. So here, in the third example, we conclude that both the speed and direction of motion is going to change. Okay, so basically, coming to the activities conclusion over here, you can come to page number 21. From the above three activities, you can conclude that the change in velocity takes place in three ways. Speed changes with direction remaining constant. This is our first example. Second one, direction of motion changes with the speed remaining constant. And the third one, direction and speed change simultaneously. So all these three were the examples of change in velocity. Do you understand? All these three examples are going to cause a change in velocity. And what is velocity? Velocity is displacement by time. Do you understand? Okay, so I'm reading it again for you. From the three activities, you can conclude that change in velocity. There is a certain change in velocity. The change in velocity can happen when the body is occurring a certain amount of displacement in a certain time. And for the body to undergo displacement in a certain amount of time, it depends on two factors. It is the speed and the direction of motion. Okay, and all these three examples show you or depict the change in velocity. Fine, look, motion of an object is said to be non-uniform when its velocity is changing. That is the definition of non-uniform motion. When the velocity is changing, the body is said to be non-uniform motion. Take the example of the inclined plane. The ball was rolling down. Okay, it was changing its speed. Which kind of motion is it? Non-uniform motion. What is non-uniform motion? When the velocity of the body is changing. So that first example is actually showing you or proving you that velocity is changing. Look at the second example. The ball was moving in a circular path and the direction of motion is changing. If the direction of motion is changing, the velocity is also changing. Okay, that is also proving that it is non-uniform motion. Now take the third example. The third example, the ball was thrown just randomly. Both the speed and direction changed. Definitely it is also non-uniform motion. So all these three examples over here depict change in velocity and they depict non-uniform motion. Think and discuss. The first one I already told you. Yes, the velocity is going to change when the ant is going to move over the curved surface of a ball. The second one, give an example of a motion when there is a change only in speed but no change in direction of motion. When there is a change only in speed but not in the direction of motion. For example, if this was the traffic signal and your car has stopped at this particular position and this is the second traffic signal and this is the third traffic signal. Okay, the car moves in this particular direction and in this particular direction. As it is moving and reaching the second traffic signal, okay, its speed increased. But as soon as it reached the second traffic signal, he applied brakes. Okay, the driver is going to apply brakes. The speed is not constant over here. Do you understand? So we need to understand over here. Give an example of motion where there is change only in speed. Is the speed changing in this case? Yes. When he started with a certain acceleration. He pushed the accelerator and he moved with a very high speed. But as he was approaching the second traffic light, he decreased the speed. So there is a change in speed over here. But if you see the direction to reach the end destination over here, it is nothing but a straight line. Okay, the vehicle is moving in a straight line, but it is coming across many traffic lights or many traffic signals and on its way. So it has to change its speed. So this is an example of an object or, this is an example of a motion where an object is undergoing a certain amount of motion and changing its speed because it is coming across different traffic signals but it is moving in the same direction of motion. It is going only in a straight line. This is just a random example. Okay. So now let's talk about acceleration. We have talked about accelerator. When you talk about accelerated in your vehicles, what do you understand by the term? Something that is, causing an instinct speed. Yes or no? When your dad is going to push the accelerator, this means the vehicle is going to pick up speed and it is going to move with a faster speed than usual. Yes or no? So, do you think acceleration is going to be decreasing and increasing both? Yes. It is going to be of both the kinds. It is going to be both decreasing and increasing. So, before this, we need to understand what is acceleration. Acceleration is nothing but the rate of change in velocity. If the velocity of an automobile or a moving person or a person in motion is changing, if the velocity of an object is changing, the rate of change of velocity, in how much time, how quick the velocity changed, gives you acceleration. So the formula of acceleration is going to be change in velocity by time taken. Do you understand? Now, what do you mean by change in velocity? Just now we were having an example. Do you remember the traffic light one? At the traffic signal, the driver was at halt. But as soon as the traffic signal showed green, he pushed the accelerator, increased his speed, and he started moving with a racing speed. Okay, that instant. Okay, the rate at which that particular velocity changed is called as acceleration. Now, the reverse of this is going to be deceleration, when the velocity is going to decrease. Okay, when the velocity is increasing, it is like moving in a forward direction. It is called as acceleration. And if it is decreasing, if the acceleration is decreasing and is slowing down, then it is called as deceleration or retardation. So basically, for example, in the first second, if a vehicle is moving with a 20 kilometer per hour speed, in the second is moving with 25 kilometer per hour per speed. So what is this? In the second, he increased 5 kilometer per hour. Do you understand? That particular change in velocity shows you that the vehicle accelerated. Okay, when you're traveling in a bus and if the bus is going to apply brakes and change its acceleration, you're going to feel a thrust towards your seat when you are moving forward, or you will either be moving forward or you're going to get stuck into your seat, or going to get feel a thrust to your seat when the driver is going to take a curved path. For example, if he is going to take a curved path and we are going to draw vectors to this, at what, and this is A, B and C point respectively, at what particular point are you going to experience maximum speed? Definitely at point B, because he's taking a curve now. As soon as the bus is taking a very sharp pin curve, you experience a thrust towards the seat. Okay, you are just being pressed towards the seat and you're holding it tight so that you don't fall down, because the speed at this particular point is going to be maximum when compared to the other points over here. Okay, that instant, that rate of change in velocity which has been caused over here is called as acceleration. Okay, acceleration is only not dealing with increasing speed or something like that. It also deals with decrease in velocity. Decrease in velocity is called as deceleration, which is like the acceleration slowing down. Okay, in the first second it was 20, in the first second it was 30, and in the second it became 25. So there was a decrease of 5 kilometer per hour. Do you understand? When you look at the speedometer, you understand what are the speedometer readings. So if your dad is driving very fast, he's at 50 kilometer per hour, but if he sees a slope and all, he decreases the speed. Okay, and when he's decreasing the speed, you can see the speedometer going in the reverse direction over here. That is called as deceleration. Okay, there is a certain change in velocity. Now, change in velocity in the forward direction or in the increasing direction will be called as acceleration or the positive acceleration. And the opposite of this is the deceleration or retardation. Okay, hope you have understood this example. At point B, the speed is going to be maximum. We have a diagram on page number 22 also explaining the same thing over here. Okay, and we have a definition also. The rate of change of velocity of an object. What do you mean by rate of change of velocity? At a particular instant, if a automobile is changing its velocity from a certain point to a certain point, for example from 5 kilometer per hour to 10 kilometer per hour, from 20 to 25, that change in velocity, that rate of change in velocity is called as acceleration. Okay, acceleration is uniform when equal changes of velocity occur in equal intervals of time. Remember our example of 0. Okay, at the 0th second, the velocity was 0. At the first second, the velocity was 2 kilometer per hour. At the second, it was 4 kilometer per hour. And the third second, it was 6 kilometer per hour, like this. Okay, so The velocities here are constant. Do you understand? So acceleration is also going to be constant over here. Uniform acceleration is the ratio of change in velocity to time taken. Can you see this? Acceleration is equal to change in velocity by time taken. The term acceleration not only applies to increasing velocity but also to decreasing velocity. For example, when we apply brakes to a car in motion, its velocity decreases continuously. From 20 it became 10 and then 0 because you have applied brakes. Okay, so we call this as deceleration. We can observe the deceleration of a stone thrown up vertically into the air, and similarly we can experience deceleration when a moving train comes to a rest. Any moving object coming to a rest, while it is coming to a rest, it gradually decreases its speed, and definitely the velocity is also going to decrease because it is going in a certain direction. So let us suppose that we are moving in a curved path in a bus. We experience acceleration that pushes us towards the outer part of the curve. Can you see this? This particular point, and when the bus takes this particular bend or this particular curve, you're going to experience a certain motion or certain thrust over here, and you feel that you're being pushed towards the outer part of the curve. You're being pushed towards the outer part of the curve over here. Okay. The motion of an object in a curved path at different instants is shown in the motion diagram. You can see the motion diagram over here. So that's all. Okay. So that is what acceleration means. We have experienced acceleration in many activities. For example, if you're traveling in a bus or a car, when the driver presses the accelerator, the passenger sitting in the bus experience acceleration. Either you're going to fall forward or you're going to move backward. Okay. Our bodies press against the seat due to the acceleration. That is what I was talking about, the thrust towards the seat when he's suddenly pressing the accelerator. If he's pressing the accelerator and increasing the speed, you're going to be moved towards your seat. And if he's applying brakes, you're going to fall forward. Okay. So further, we will talk about equations of uniform accelerated motion in the further video. For now, the Sakshi is page number 20, 21 and 22 done. I want you to solve, think and discuss on page number 23. Okay, I'll write down the Sakshi for you. Sakshi is classwork page 20 to 22. Done. So what all did we talk about? We talked about uniform and non-uniform uniform and non-uniform motion. Then we talked about 3 examples over here where there could be a change in velocity. And the first one, the speed was changing but the direction of motion was not changing, and it was the inclined plane example. The second one was rolling the stone where the speed is constant but the direction is changing because the stone is moving in a circular path. And the third one, the stone was randomly thrown up in the air, so it was changing its speed as well as its direction of motion. All these 3 examples state change in velocity. If there is a change in velocity and if the velocity is not constant, then this kind of motion is called as non-uniform motion. Then we talked about acceleration. Acceleration is the rate of change in velocity. Okay, the rate at which the velocity is changing. How much the velocity is changing. Do you understand? That is going to give you acceleration. So now, of course, the time is also a consideration over here. We also studied about deceleration, which is when the acceleration is decreasing. Also, we studied a motion diagram and where the speed is going to be maximum. We have stated many examples of acceleration while you're moving in a bus, moving in a train, and you're getting pressed towards the seat when the driver presses the accelerator, and when he applies brakes, you're going to fall forward. Okay, so here, classwork is page 20 to 22 done. Page 22 done, and homework is solve, think and discuss on page 23. Try to solve it. Okay, of course, if you're not able to do, I'm always here to explain it again. Fine, we will definitely discuss about think and discuss in the other video also. But for now, I wanted to try it out. I wanted to think logically and critically. What are those think and discuss on page number 23 and try to solve them. Use a pencil if you're doing it in a textbook. For now, yes, this was an easy topic. Thank you for now.